We're ready to begin part 2 now in this section on Tanzu mission control. Now, in the previous video, we explained the value that TMC offers to customers who are looking to manage the life cycle of their Kubernetes clusters. And we also created some resources in the UI portal in front of us, which allowed me to better explain some of the main features in TMC. Now, you'll see that I deleted all of those resources, the cluster group, the clusters, as well as the AWS credential. Now, in this video, we're going to create all of those resources again in our bash shell script from start to finish. Now, that script is located in the tmc/create folder called tap clusters AWS create in our cloned repository. So I've got this command queued up. We'll go ahead and launch this. And the first prompt is for the organization. And if you've seen the previous video, my Tanzu mission control that we're using is in my NYC pivot organization. For subsequent videos, when we demonstrate different services such as Tanzu observability or Tanzu service mesh, I'll need to log into this customer 0 organization. Okay, so let's get this rolling here. And while that's running, we'll go ahead and talk through the rest of this script here. So we've already set our ARIA org variable to NYC pivot. We're then collecting just some of my AWS account details. And now on this line here, I touched upon this briefly in the previous video. This account ID is not a randomly generated account. It's actually based on the name that you give your credential. So some kind of algorithm is running behind the scenes so that if I always use this name, I can absolutely be assured that I will get this account ID. I've tested this again and again, and I've tried workarounds to not depend on this ID, but unfortunately, this is the situation we find ourselves in. If I were to change just one character in this, I would get a totally different ID. But nevertheless, if I changed it to account credentials, I would get the same ID again and again. So that's just the way it is. And if I was in a different organization, I would even get a different ID as well. Now, these other unique identifiers, the external ID, I'm not quite sure what this is for, but that's part of the template. And this ID here is my NYC pivot organization. Okay, so we're just storing those off into those variables. Scrolling down here, the next point I just want to touch upon is the account ID that TMC is actually using behind the scenes. We don't have access to this account. We can't see it or touch it. And so this is how TMC does its magic here. And so I put together just a very primitive diagram here for those who might not be familiar with AWS cross-account access. Basically, what we have here is two AWS accounts. This is my account on the right-hand side. And on the left-hand side, this is the account TMC is using. And that ID that we just saw would be associated with this account on the left. Now, I don't even know what resources or services or roles or whatever is even using the access to get into my cluster. So I'm just depicting that with the logo here of VMware, Tanzu. So these IAM roles were created from our CloudFormation stack. And so that's how TMC will assume the role necessary. We have cluster lifecycle, control plane, worker. And so when it assumes that particular role, it's able to create our EKS clusters, our EC2 instances, and so forth. So that's what we're doing now. So we're creating the stack, okay, with the same URL that the portal gave us, okay? When it generated the CloudFormation stack, we can do all of this in our bash shell script. Then, if you'll recall, the next input that was required in the portal was the role ARN that was generated by the stack. Okay, so that's what we're fetching here. So once the CloudFormation stack completes, we're going ahead and getting the role necessary. And this role ARN is necessary to pass in to some of the configurations needed to create our resources in TMC. And we'll see that shortly. Okay, then I am getting the token that I'll need in order to use the TMC to log on to the TMC portal through the CLIs. And I'm fetching that from AWS Secrets Manager and storing those away in their respective environment variables. Now I'm doing it twice because if you'll remember, I'm using the TMC CLI, which is being deprecated in favor of the Tanzu Mission Control plugin. Okay, so that's the point of doing it twice. Then we're creating our TMC operations cluster group, which is a very simple process there. And what it's actually running now down below is it's creating our AWS account credential. Okay. And so we pass in a YAML configuration file with all the variables that we've already talked about. And we pass that in through the TMC CLI credential. Now, TMC is by no stretch of the imagination here giving me a progress of how much time is remaining. This is really just an ad hoc timer that I've put together here just to give me a sense so that I can take a glance, multitask, and come over here and see how much time is remaining approximately. Now, this is probably more than enough time that TMC needs to create the credential, but I just want to make sure that it is created because I don't want commands subsequent to that to overlap, because this credential has to be created before we start creating these clusters, which is next. Now, I also did a check just to see if TMC or the Tanzu Mission Control plugin offers a wait flag. TMC doesn't, and the Tanzu Mission Control plugin does not. Tanzu itself might, but I prefer this anyway, even if it did, just so that I can get a quick glance at the time remaining. Okay, so we've got just a little over 10 minutes remaining. We will come back as soon as this procedure has finished. Okay, so with less than a minute remaining, let's go over to the portal then and take a look. We just want to refresh this page and we should see, yep. And so there it is. We've got our AWS account credential in the valid state. So now we also have our cluster group called TMC operations. Okay, and if we come over here, the process should have kicked off the creation of our first cluster, the tab view. And that's exactly what we see. So let's go back over to the script and talk about this section. So we finished creating the credential, and now what we need to do is retrieve the values of our VPC, the VPC ID, the 4 subnets. Now, in a previous video, we saved all of that off into this JSON file when we created the Tanzu VPC stack. Okay, so we just saved that off into the file rather than going out to AWS and getting it. So the currently executing code is this step right here. So we're creating our 3 EKS clusters. Now, you'll recall that this, again, this is a 2-step process. So we're first creating the control plane node. Let me just drop this down a bit. We're first creating the control plane node, all right, with the control plane role that was created by our CloudFormation stack. And once we create that, we pass that configuration off to the Tanzu Mission Control plugin, okay, and we just give that a bit of a, and so we just give that 60 seconds, right, to queue that up. And then we get to the node pool or the node group. Now, let me just explain this, the differences here. They're really one and the same. It just depends on who you talk to, right? So whether you're talking to EKS, you know, they call it a node group. Whether you're talking to AKS, I'm not sure if they call it a node pool, or TKG or TMC for that matter, they call it a node pool. And the whole point of these is to group our instances in these node groups. Okay, I found a pretty good diagram here that I'm just going to bring up. So one of the use cases for creating multiple node groups within an EKS cluster or any cluster would be for the purposes of setting up a blue-green environment. This is actually the first time I've seen this use case. So if you're familiar with blue-green, in our production systems, we have our running production application. And then when we have the next release of the software, we would want to test that into a separate environment, which we call green, make sure that that all looks fine. It passes, our approval processes and so forth. And so what we would want to do then is shift the traffic from the current version of the application in the node group blue environment over to the green environment. So that's the idea of a blue-green deployment. Now, usually I've seen this where you just spin up different clusters. I would have a blue cluster and then I would have a green cluster. Here, what AWS is suggesting is you can have one cluster and create a node group with all of your EC2 instances in that group, and then create another green and create all of your version 2 node instances and so forth. And so then you just modify a DNS entry of sorts so that traffic is, or an ingress probably, so that traffic is now routed to the new release. Another use case that I've seen before are where we want to take advantage of GPUs, right? So in normal circumstances, like in ours, for example, we're just spinning up T3 instances with normal, vCPUs. But then we can have a node group separate from that, where we're taking advantage of GPUs, maybe for AI and machine learning, things like that, that require that kind of processing power. And so we can have one cluster where we're having workloads run on the normal CPUs, but then we can take advantage of other instances in a separate node group that is using GPU compute power. Okay, so back over in our script here. So that has finished. So we talked about the control plane being created. And here you can see that in order to spin up the EC2 instances, our TMC AWS account will assume this worker role in order to do that. Okay, and we're spinning up 2 instances within the node group. Now, once again, we've got our superficial fancy timer running here. So in under 45 minutes, we're giving TMC to spin up 3 EKS clusters and install all of its agents and extensions. So we will hope for the best that it can do that in that time frame. So we will return once this has completed.